Hello grade 8s. Today we're going to be looking at another type of percentage question. So this time we know a percentage but we want to find the original quantity. We're going to look at two different versions or two different methods for this, and we'll go through these three examples. So the first question, we know that 20% of a class wears glasses, and we know that there are 10 kids who are wearing glasses. Now, some of you might be able to work this out quite quickly just by using the ideas of proportion. There are many ways that you could answer this question. I'm going to focus on two methods. One method is where we have a little table and we have one side percentage and the other side the amount. So we know that 20% of a class wears glasses, and we know that that refers to 10 students. What we want to find is how many students there are in the class. We want to find 100% of the class. And what we're going to do, actually we could probably do this in one jump. We could go from 20% to 100% by multiplying by 5. There are lots of other ways we could get there. We could halve it to get to 10% and then times by 10 if that's easier. But it's okay to times by 5. So we'll do the same to this side. So we're always going to be multiplying and dividing when we do this method and doing the same to each side. So 10 times 5 is 50. There must be 50 students. A large class compared to what we're used to. An alternative method will be a more algebraic approach, and that's to say, let's say the letter n is equal to the number of students in the class. And what we've done is we've said 20% of n is 10. Now if we knew what n is, we'd work that out, possibly, by turning into a decimal and multiplying. And of course, to find n, we can undo this operation. The opposite of timesing by 0.2 is dividing by 0.2. So I could do 10 divided by 0.2. So let's check that quickly. 10 divided by 0.2 is 50, just as we'd expect. Okay, so these are the two methods that we're going to use. Example 2, the area of Lake Winston is about 75% of the area of Lake Albert. So that means Lake Winston must be smaller than Lake Albert. We're told the area of Lake Winston, and we want to find the area of Lake Albert. So let's use this method this time. Let's say A is the area of Lake Albert. So Lake Winston is 75%. We could do that as a fraction or as a decimal. I think for the purpose of this video we'll stick with decimals. So to find 75%, we'd do 0.75 times the area of Lake Albert, and we would have got 36,000 kilometers squared. So to find the original, we're going to have to undo this. We're going to have to divide. Let's check this. 36,000 divided by 0.75. is 48,000. So the area of Lake Albert is 48,000 square kilometres, larger than Lake Winston, which is what we're after. And if we think about this, 36 is 3/4 of 48. Okay, we'll do one more example, and for this one we'll use this table method. Sorry, let's get rid of that. Okay, 48.5% of the town of Mulberry are males. There are 27,000 males in Mulberry. How many total people are there in Mulberry? So let's set up our table. We've got percentage and amount, or you could put people here, I guess. We know 48.5% of the town are males, and that is equal to 27,000 males. We want to find all of the people. We want to find 100%. Now, there's not a simple way of multiplying up to 100. So, one number we can always get to is 1. Because to get to 1, we just divide this by itself. Let's use a different colour to show what's happening. So, going to 1 is always a safe option. I just divide by 48.5. I could have done that with this method. I could have divided by 20 and got to 1, and that would have worked there. So if you can't see an easy way to get from the starting percentage to the end percentage, it's always safe to go via 1. So I just have to make sure I do the same on this side. Let's check that. 27,000 divided by 48.5. Oh, not a particularly nice number. Let's say 556.701. That's 556.701. It kind of goes on, doesn't it? Doesn't seem to be any sort of pattern. Right, how do I get from 1 to 100? Well, once you're at 1, it's easy to get to anything, isn't it? So that is the great advantage of this method where we go through 1. I just times by 100. 1 times 100 is, of course, 100. And I'll times this side by 100. So, 70.1 ... Now, let's just think about the context. We're talking about people. So let's say 55,670 people. That seems more sensible than having a decimal, doesn't it? Folks, I don't mind which method you use. You could use this algebraic approach. You could use this table method, which is very versatile, or you could use another method of your own, provided I can understand what you are doing. Good luck with today's work.